Hi, welcome to my channel, JaberTime. Let's go over exponential functions, which is written as a times b to the power x. To find b, here's a shortcut. y2 over y1 to the power 1 over x2 minus x1 if you're giving 2 points. Let's get started. A car was valued at $41,000 in the year 2009. By 2013, the car value had depreciated to $15,000. If the car's value continues to drop by the same percentage, what will it be worth in 2018? 2018 from 2009, that's 9 years from the starting time. Round to the nearest dollar. This is the formula, a times b to the power x, where b has to be greater than 0 and b cannot equal to 1. Well, of course, b has to be positive, but if b equals 1, you're going to keep multiplying by 1 to the power something which is not going to go anywhere. It's going to be a horizontal line, y equals 1. So that's not exponential. And of course, it cannot be equal 0 because multiplying by 0 all the time is not going to take you anywhere. Negative is not allowed also. It's not part of the game. Because if you keep multiplying by negative, for example, 3 to the power x, the outputs will be positive, negative. They will keep escalating between positive and negative. So it's going to go up and down below the x-axis and above the x-axis, which is not exponential. And that's the reason why we have those conditions. Now, to translate the problem into coordinates and values, I have the following. x1, y1 equals 2009 with $40,000. That's from the first part. And x2, y2 will be 2013 and $15,000. In 2018, we need the value. This is how we start. Time will be t, years since 2009. That's the starting time. V of t will be the value of the car after t years, the number of years. So we have t, v of t, where v of t equals a times b to the power t. Now, this right here is not the practical way to use. So for 2009, we're going to have to use 0. Because when we start, we are counting time, and time is 0. In 2010, 1 year passed, so we are going to use t equals 1 for 2010, and so on. So to make this practical for the problem, we have time and value. 0 corresponds to $41,000. And 4, because we're going to go from 9 to 2009 to 2013, that's 4 years. So that's the 4 right here. And of course, if you go from 2009 all the way to 2018, that's 9 years. So 2018 in our numbers right here corresponds to t equals 9. 9 years since 2009. We need the value at 9, t equals 9, which is 2018. Y equals a times b to the power x. A will be the initial value. In this case, will be $40,000. And b is, as I mentioned earlier, it's y2 over y1 to the power 1 over x2 minus x1. To see how this works, I'll give you an example first, then I'll go back to this problem. I want to show you why this is true. I mean, you could use it, but it's good to know why it looks like this. Here's an example, a simple example. Assume we start with $5. So A is 5. And we double the amount every day. So we have 1 gives you 5, 2 gives you 10, 3 gives you 20, and so on. 20, 40, 80, 160, 320. To make it practical, we start with 0, not 1. So when time is 0, That's we are on day 1. When you go to the second day, 1 day passed, and that will be 10. So from now, we count the time as 0. So 0 corresponds to 5 or gives you 5, 1 gives you 10, and so on. Same numbers, but start with 0. To see it as kind of like coordinates or a table, this is what's happening. This would be easy if you go by 1 and you don't skip anything, so you could see the pattern. We're going step by step. We're not skipping any steps. And the outputs are being multiplied by 2, by 2, by 2, by 2, which we talked about earlier. Going backwards to reveal b, the factor that you're multiplying by, you could see that 320 divided by 160 is 2. Going back this way, 160 divided by 80, which is 2. So it's always 2, and it's clear to find b. But sometimes that's not the case. To support that, 40 divided by 20 is 2, and 320 divided by 160 is 2, so b is 2. We could see that. Now, let's focus on 110 and 480. If you are giving 110 and 480 and you're told that this is happening as exponential growth, how would you find b? Well, we could see from the table right here, it takes me 3 steps. So multiplying by 2 3 times. As you can see, we're skipping steps. We're not going straight forward from one point to the other point after. So 110 and 480. That will be my first point, x1, y1, and x2, y2. To see what's happening, I'm going to start with 10. I want to go down to 80, multiply by 2, multiply by 2, multiply by 2. So I'm going to have to multiply by 2 3 times, as you could see. Alright, so 2 to the third is 80 over 10, simplifying. And to solve for b, which is, we know already that it's 2, I'm going to apply the power 1/3 to both sides, or the exponent, to cancel the 3. And that will say the cubic root of 80 over 10, which is 8. Cubic root of 8 is 2. As you could see, indeed, it's true. If you look at this and look at the shortcut, it's pretty much the same thing. 80 over 10 is y2 over y1. That's y2 over y1. And 1 over x2 minus x1. To go from 1 to 4, step by step, it takes you 3 steps. 4 minus 1 is the 3. That is 4 minus 1. So that helps to understand where this formula is coming from. Now, b is 2. We could see it in a lot of different places here, and we showed that how to apply the shortcut to find it. b is 2. What is a? We know that a is the initial amount, which is 5 right there. But let's say we don't have 0, 5. We don't have the other points. I don't have the whole table. I only have 2 points. How do you find a, which is 5? We go back to the formula, and we're gonna put for b2, plug in 2 for b, and we're gonna use a point. I think this one, 110, is easier to use than 480. You could use whatever you want. I'm gonna use 110. 1 for x and 10 for y. So 1 for x and 10 for y. Solve this. A times 2 equals 10. So a is 5. So that also supports the concept. Understanding enough about exponentials and with simple examples helps a lot applying it to other problems. So y equals 5 times 2 to the power x. Now let's just check. Let's take the last point, 6 and 320. Apply it. Well, 6 is my x, and to find y it should be 320. 2 to the power 6 is 64. 64 times 5 is 320, so that is true. Let's go back. So we have this problem. That's our problem. We're gonna apply this right here. b equals y2 over y1. to the power 1 over x2 minus x1. In this case, that's my y2 and that's my y1. So I'm going to divide 15,000 over 41,000 to the power 1 over x2 minus x1. As you can see, I'm using colors to show you where it's coming from. Zeros cancels, and we have 15 over 41, and that simplifies to 1/4. I know this is not simple like b equals 2 in the previous example, but that's going to be decimal, and we're not supposed to round while we're solving. We wait till the end and we round our final answer. So this is approximate. That's what the calculator displays for b. So going back to the formula, v of t equals a times b to the power t, and b is what is written right here. I'm not gonna read the whole thing, it's a waste of time. So we put it in. A is the initial amount, which is 41,000, and v of 9, that's what we want. V of 9, use a calculator to evaluate this, and you get this much. They want us to round to the nearest dollar, so I'm gonna eliminate this part right here and write it without 0.010821. So the car will be worth about $4,268 in 2018, and that should do it. It's about 9 minutes, or about, I think that helps to understand the shortcut and the exponential functions with a and b. A initial and b is the factor that you keep multiplying by, which is b for base, I would say. Okay, thank you, and I'll see you in the next one. Thank you. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.